This is Algebra Lesson 4.9, Solving Systems of Equations by Elimination, Day 2. Now, by way of reminder, I want you to see the steps that we did yesterday on solving a system by elimination. We combine the equations and eliminate one of the variables. Then the variable that's left in the equation, we solve for that. That's step 2. Step 3, once we've solved for that first variable, we plug it back into one of the equations and solve for the other variable. Then we write an ordered pair and then check our work. Now, the one thing that'll be perhaps a little bit different today than yesterday is this first step, in that combining the equations to make the zero pair might not be quite as straightforward as it was yesterday. We'll have to get a little bit creative to figure out how to get our variables to eliminate. So you'll see when we do the first one. So let's take a look. 3x minus 2y equals 19, and we have 5x plus 4y equals 17. Now, if you were to combine those together, neither the x nor the y would be eliminated. And unlike yesterday, when we multiplied by -1 to make them negative or positive, that's not going to help us either. So we have to get a little more creative. So what I'm going to suggest is that on this top equation, we multiply it by 2. Well, what will that accomplish for me? Well, if we multiply by 2, and that means we multiply everything by 2, this middle term right here is going to end up being minus 4y. Then when we combine the equations, the positive 4y and the minus 4y will become a zero pair, and the y's will get eliminated. So let's go ahead and do that now. I'm going to multiply everything by 2. So I end up with 6x minus 4y equals 38. Now I'm going to just bring the other equation and put it underneath. Now when I combine these two equations together, I end up with 11x. The 4y's cancel out, and we get equals 55. Now we divide by 11, and x equals 5. Okay, so now that I know that x equals 5, I can look at my two equations that we had originally, and I'm going to erase this part, and say, let's plug 5 into one of them and solve for y. So I'm going to use this second equation. You can use either one. It'll work either way. So here's 5x plus 4y equals 17. And so I'm going to replace the x right here with 5. So 5 times 5 plus 4y equals 17. Now let's subtract 25 from both sides, and I get 4y equals -8. I'm going to divide by 4, and y is going to equal -2. So our solution to this system of equation is x is 5 and y is -2. There's our coordinate pair. Always write it as a coordinate pair. I don't want to see you go like this and like this. The solution is an x and a y together solves the system. And now to do a quick check, I'm going to use the other equation, 3x minus 2y equals 19, and I'm going to put our solution in there. So I have 3 times 5 and -2 times -2 equals 19. And so this is 15, -2 times -2 is positive 4, and so I get 19 equals 19. And there, we've checked our work. Okay, so that's number 1. Pretty easy, right? So let's try number 2. So on number 2, again, we're going to have to look over these equations. There's multiple ways that you could do this, but I am going to take the second equation and multiply it times -2. That's going to help me eliminate the x's. So I'll show you what I mean. I'm multiplying all of these terms by -2. So I have -2x minus 4y equals -28. You have to be careful with your integers here. Some of you with your negatives and positives, you have a little bit of trouble. I am just rewriting the top equation right there. And now we combine the equations. Our x's cancel out. and negative 4y plus 1y is going to be negative 3y. Negative 28 plus 4 is going to be negative 24. Divide by negative 3. And a negative divided by negative is a positive, so that's positive 8. So now that I know that y equals 8, I'm going to plug that into either one of these two equations. So I'm going to use the top one, 2x plus y equals 4, and instead of y, we're going to substitute 8. And now I'm going to subtract 8 from both sides, and I get 2x equals negative 4. Divide by 2, and x equals negative 2. So our solution to this system of equations is x is negative 2 and y is 8. 2 comma 8. Bada bing, bada boom. Right? Now, let's check our work real quick. So I'm going to do x plus 2y equals 14, and let's substitute negative 2 plus 2 times 8. So negative 2 plus 16, and negative 2 plus 16 is 14. And there we go. It checks. Okay, so let's move on to number 3. We have to get even more creative with number 3. And so you can look this over and make a decision. Again, the way I do it is not necessarily the only way. But what I am going to do is I'm going to take the top equation and I'm going to multiply it times 2. And I'm going to take the bottom equation and I'm going to multiply it times negative 3. Now what's that going to accomplish for me? I'm going to end up with a negative 6 on the top and a positive 6 on the bottom, 6y that is, and that'll eliminate my y's. So let's go ahead and give it a try. So I'm multiplying everything. I get 8x minus 6y equals 24. And then for the other equation, we get negative 9x plus 6y equals negative 12. Now let's combine these two equations together, and 8x minus 9x is negative x. These cancel out, equals 12. Now we don't want to solve for negative x, we want to solve for positive x. So this is really negative 1x, so we're going to divide each side by negative 1, and x equals negative 12. When you divide by negative 1, the only thing that changes is the sign. So x equals negative 12, and now that I know that, I'm going to take that negative 12 and plug it back into the other equation, one of the equations, and solve for y. So I'm going to use the top equation, 4x minus 3y equals 12. And so 4 times negative 12 minus 3y equals 12. So this is negative 48. And now I'm going to add 48 on both sides. So we get negative 3y equals 60. And divide by negative 3. And y equals negative 20. So now we have our ordered pair. X is negative 12. Y is negative 20. And if you'd like to check your work, we can take, I'll take the bottom equation there and say 3 times negative 12 minus 2 times negative 20 should equal 4. So that's negative 36 plus 40. Negative 36 plus 40 is 4, and it checks. Now, how about you look over number 4 and see if you can solve that yourself. So why don't you hit pause and give it a try. Okay, so the solution to this equation was negative 1, or is, not was, is negative 2, negative 1, negative 2. There's our ordered pair. So if that's what you ended up with, great. You could probably fast forward or just watch me very quickly and go to the next one. Or if you did not get that, let's watch me solve it. So I decided to take the top equation and multiply it by 4, and I took the bottom equation and multiplied by -3. Now I'm going to pause while I do some of the multiplication. Okay, so you can see with the blue I multiplied by 4, and the red is being multiplied by -3. When I combine these, the x term is the one that eliminated, and we ended up with -17y equals 34, so y equals -2. Now you should be getting pretty good at this next step, which is taking your value right here for y and plugging it into one of the other equations. So I'm going to use the top equation, which is 3x minus 8y equals 13. So 3x minus 8 times -2. And so we get 3x plus 16, because a negative times a negative is a positive, equals 13. I subtract 16. I get 3x equals -3, divide by 3, and x equals -1. And so our solution to this equation, as mentioned earlier, was -1, -2, and there you go. Okay, check your work, and let's move on to the back page. Okay, so we have a family in the neighborhood contributing $20 worth of food to the neighborhood picnic. The Harlan family is bringing 12 packages of buns. The hamburger buns cost $2 per package, the hot dog buns $1.50. How many packages of each type did they buy? So this is what we're looking for. So that's going to be where we're going to derive our let statement. So this one's a little hard because they're both buns, begin with B's. Hot dogs, hamburgers, both begin with H. So I'm going to say let B equal the number of burger buns. And I'm going to let H equal the number of hot dog buns. Now let's write two equations. We get B plus H equals 12. Because there were a total of 12 packages of buns. Now, the second equation is going to deal with the cost of the buns. So the second equation is going to be 2 times B plus $1.50 times H is going to equal $20. Now, we're using elimination on this, so I find that the easiest way, especially when I have variables where the coefficient is 1, I look at the second equation and I pick the coefficient that's the smallest, and that's what I multiply by on top. And so I'm going to multiply the top by -$1.50. And so I'm going to do that down here. You'll see we get minus $1.50B minus $1.50H equals -18, because I'm multiplying that times all three parts. Combine the equations, and we get 0.5, or 50 cents, B equals -2. Excuse me, not -2, just 2. So sorry about that. Now we divide by 0.5, and B equals 4. So that's the number of packages of burger buns they're going to bring. Now, to get the hot dog buns, we're just going to take that 4 and plug it in, and we're going to do the equation that's easiest, which in this case is definitely the top one. So we're going to say, rather than B plus H equals 12, we're going to say 4 plus H equals 12. So subtract 4, and H equals 8. So our solution to this system of equations is 4, 8. Now the question comes up, how do you know which one to use or put first when you're using variables that are not x's and y's? It really doesn't matter as long as you have them labeled. I personally like to put them in alphabetical order, so I put the burger buns first and the hot dog buns second, but I like to put my variables up here on the top so that I can see which one is which. And so there's my answer. 4, 8, burger buns and hot dog buns. Okay, let's go on to number 6. This is our last problem. The Lees spent $31 on movie tickets, for 2 adults and 3 children. The Messiahs has spent $49 on 3 adults and 5 children. What are the prices for adult and child movie tickets? So that's what we're looking for, the price of the tickets. So that's going to help on our let statements. And I'll tell you what, why don't you hit pause and try and do this yourself, and then I will walk through the whole problem, okay? So try it, and then come back. Okay, so the solution to this system is 8,5, 8 being $8 for adults and $5 for children. You can see that down here. So if that's what you got, wonderful. If you did not, then I want you to watch how I solve this. I have let A equal the price of adults, let C equal the price of children, and this first equation is for the Lee family, and the second equation was for the Messiah's family. And so in order to solve this, what I chose to do was take the top equation and multiply it by 5, and I took the bottom equation and I multiplied it times -3. That's going to help me eliminate the C's that are in the middle. Okay, so I'm going to do that, ching, 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 like that, and we get 10A plus 15C equals 155. And then the lower one, we get -9A minus 15C equals -147. Now, when I combine these two equations, the C's get eliminated, and I end up with A equals 8. And once I know that A equals 8, I can use either of my two equations to find C. And so I'm going to use the second equation. So I have 3 times 8 plus 5C equals 49. And so that's 24. Subtract 24 from both sides, and you get 5C equals 25. And divide by 5, and C equals 5. And so therefore, we had adults at $8, children at $5, and there is our solution. Okay, now that video took me a little longer than I planned, but hopefully it's helpful to you. You should be able to do elimination now. We've done it now for a couple days, and I'm hoping you've got the hang of it. Of course, come to tutoring if you're having trouble. Okay? See you in class. Take care.